Good morning, everyone. We are pleased to welcome you at this session about the new solutions for expansion management. We have today Jonathan Vlastwin, who is Regional Marketing Manager at Danfoss for Europe and the air conditioning segment. And he's your contact for today. So don't hesitate to ask your questions in the chat box, in the question box. You will be muted by default, and this session will be recorded. So don't hesitate to reach out to us because you're muted, but don't hesitate to reach out to us via the chat or question box. Thank you very much. Enjoy the show. Bye-bye.
Thank you, Laure. Good morning, everyone. Thank you for joining us. Today, the topic is new solution for expansion management. I will talk about the new products we introduced at Danfoss, why we introduced that, and what you can do with the new products we introduced today for all the devices you may design in the future. So here is the agenda of the presentation. First, I will spend some time on the driver for those kind of innovation, why the market is pushing us to develop those kind of products. And then we will talk about the electronic ecosystem we have built at Danfoss, the EXV, the superheat controller, and so on. And finally, I will spend some time about what is new in the family in this ecosystem I've presented. So some time on the ETS5M, ETS Large, and what we call the EKF driver. Okay, so let's start with the innovation driver. Why we do everything? You have here 5 pillars we use at Danfoss to derive the strategy. The bigger one is climate change, obviously, and practically all of the other pillars comes from the climate change. As you may know already, 40% of the consumption of energy in the world is due to building, and it impacts 25% of the emission comes from the building. So climate change is really driving everything else. So it's driving electrification, it's driving also food supply, because there will be more and more difficulties in the food supply, and so ensuring that the food is correctly and properly transported cold to cold everywhere in the world is one of the key components of the new transition. Urbanization also is a derivative from the climate change. More and more people will live in the city to reduce the distance they have in between the work and where they live, and so on. So we can move along path if we start discussing about climate change. But to summarize everything, this pushes us to make a lot of efforts in terms of efficiency, and the new regulation about efficiency will push us and all the business to move to more viable technology for HVAC system, for instance. And that is why electronic expansion solution may be needed. I will insist on this one later on. And as also refrigerants are quite a consistent share of the green gas emission. Let's talk about 2% of it approximately. So same order of magnitude as aviation itself. No regulation are pushing to have low GWP refrigerants. So that is why also we have introduced new products that are certified for more refrigerant. I will come back to this. So let's start with some very simple schematic and TXV. So the way most of the devices and a lot of devices usually do the expansion. So here you have a very simple condensing unit schematics that is using a TXV. TXV can regulate superheat, so meaning you have a probe that is connected to the end of the evaporator, and then very simply, mechanically, it can open or close the valve so that the superheat is regulated to a certain value you have set up once and for all in your factory. This is very reliable, this is simple, this is cost competitive, it has worked for decades, and it will still work for many applications. But it has some limitation. The modulation range is limited to 30% to 100%. That may be enough for many applications, but that may not be enough for a lot of different variable speed application. I will insist on this one later. And it's also a single flow solution, meaning that if you want to have reversible chiller, you have to double the number of thermostatic valves you use. You have to add some check valve and so on. So you have to complexify a little bit the system you're building. That is why we introduced the EXV. So here I will spend some time on this one because it's really set the scene for why we're using EXV. You have on the left typical TXV, and you have the competitive solution, so the equivalent solution when you go into electronics. So on paper, it looks like much more complexity added just for doing the same function. You have to have a controller or driver, you have to have a valve, you have to get sensors, everything has to be regulated through some kind of intelligence. So yes, on paper, it adds complexity. So why doing that? Then you have to look at the envelope you have for different kind of application. If you look at that envelope, this is a variable speed compressor envelope that is a draft for 2 different speeds. In gray, you have the very low speed, and in blue, you have the high speed. The envelope here is the compressor plus the valve, meaning that the valve, the thermostatic one, is probably limiting the capability of your machine to work efficiently at high speed and low speed. At some point, you have to make a compromise, whether you want to reach some of the point at high speed and some of the other point at low speed. Don't get me wrong, that may be sufficient for many applications. That's why TXV still have a very good value proposition for many applications. But if you need to have more capability or more modulation, you need to go to the solution on the right here, because you see that with an EXV, the very same compressor, which is a variable speed VZH we have at Danfoss, you plug in with an E-valve, which is in that case a colibri valve, and you see that the part load and the full load envelope are matching quite better than what you had with a TXV, meaning that with the valve, electrical valve, you're able to match very much more the envelope of the compressor, and this is what you want. You don't want the valve to limit the capability of your compressor that is maybe 10 times the price of what you pay for the valve. And as you enter the world of electronics, then it becomes possible to start imagining a lot of new features, meaning that you have temperature sensors, you have pressure sensor, meaning signals, you can record that, you can some data collection, you can do, starting from there, cloud computing to do some predictive maintenance. You can regulate much more better the superheat with more accuracy, more speed. You can start imagining also a smart transient behavior like smart start off and all those kind of things. You can start designing your unit, taking into consideration that the flexibility that is added by electronic world can be a benefit for you. So that is why we have an electronics ecosystem now at Danfoss, and I will show what we have today. So this is the whole portfolio of products we have in that range of expansion management being done by electronics. So we have here the HVAC controller, what we call the MCX. So this is the main brain of your units. And we have a whole platform of EV. I will go into the detail from these 2 ones, so ETS 5M and the Colibri. We have the full range of temperature sensor, pressure sensor, all kind of different featured for your application need, dedicated to your application need. There are also other devices that go around the expansion. That is just not only the valve plus the control. You have power backup module. This one, EKE2U, using capacitors, helps you closing properly the valve when you have a failure of chiller. You don't want the chiller or your compressor to be flooded when you have a failure. You want the valve to close properly to avoid any slug in your compressor when you start again after you fix the failure. So this backup power module ensures that the system is closed properly when you have a failure. You have other kind of devices that goes around that ecosystem. You have the programming tool, so meaning that you can do the home programming of the superheat controller, of the main controller. You have also services, devices such as this one, the user interface that the maintenance people can use to act and to do the maintenance on the different chiller or any HVAC machine you may want to work with. And in the center, you have the superheat controller. We have the EKE, which is, I will go into the detail for this one. We have EAIM, and we have also a driver that I will introduce at the end of the presentation. We call the EKF. So let's first start with the valve. So here you have the whole offering from Danfoss when it comes to electronic valve. It covers the range of, let's say, 500 watts until 3.3 megawatts. So you can cover most of the application we have in the market, for very small ones up to very large ones. The first on the left, ETS 5M, I will go onto this one later on, so I don't spend too much time here. Goes from, let's say, 700 watts of 14A to 20 kilowatts of 14A, meaning it's very suitable for small applications such as residential heat pump, VRF, food transportation, etc., etc. I will go later on this one. We have also the ETS 6, which goes up to 46 kilowatts of high density refrigerant, and then for chiller in between 20 kilowatts up to 400 kilowatts, or sorry, 600 kilowatts, we have the Colibri family. The Colibri family is a very elegant solution for doing the expansion. It's the inline component, so meaning you don't have like the ETS Large, the motor that goes in another direction. It's very compact. You have a side glass incorporated. And it's very much appreciated by all the customers that currently buy this one. It goes from a very small capacity, let's say 100 kilowatts of 14A, up to 600 kilowatts of 14A. And after that 600 kilowatts of 14A, normally the chiller, they don't use so much high density refrigerant. They move to lower density refrigerants. 134A is currently used, and it's moving slightly to ZE or other kind of low density refrigerant. For those big chiller, we have a family of what we call the ETS Large, going from the 175L up to the 550L. I will introduce also a new products in that family range later on. And even bigger, for even bigger solution, very large chiller, several megawatts, we have manifolded the ETS Large, and we introduced two bigger valves, 800P and 1100P. After the valve, there is also another device which is very important to do the expansion. You need to control the valve. You need to send it a signal, open or close. For that, you have a superheat control. The superheat controller is really designed so it can mimic what we had with the TXV. With the TXV, you don't need any sort of intelligence. It does the regulation itself. You just need the valve. If you switch to electronics, you need some kind of intelligence that is getting the feedback from pressure and temperature sensor and is able to drive the valve, saying it to close or open regarding a certain setting in superheat. This is what the EKE or the superheat controller is doing. This is a standalone solution that you plug on the main controller, but basically it can drive the valve and do all the work of translating the signal of pressure and temperature into closing and opening a signal for the valve. It's connected through a Modbus or CAN bus to the main controller, and it comes with different versions. You have a very simple one, which is called the EYM for very simple and very simple application, very cost competitive ones. And if you have bigger needs, you need more power to drive your valve, such as Colibri, you start to get some big valves, then you need something that is called the EKE, and that comes in different versions, 1A, 1B, 1C, depending on the feature you require, the number of IOs, the kind of valve you drive, the kind of signal, kind of sensors, and so on. So you have a whole ecosystem of different solutions you can use to drive your valve. What is new about all of that? What is new in the ecosystem of superheat control and expansion? First, I've talked before about the ETS 5M. This is the smallest valve we have, and we have to introduce this one a year ago, actually, but we expanded the range of what it can do today, especially the range of refrigerants which is certified for. Actually, the ETS 5M was designed for VRF solutions, so noise was really a strong focus for the ETS 5M. That is why now the result of that is that the ETS 5M is a quieter valve there is on the market for that. It's very compact as well. It's very important for those applications, so VRF, small compact application, to have something that fit in small spaces. So the two main characteristics of those valves are really to be quiet and compact and very versatile in the way you can put that into your application. You will see on the drawing on the next slide that it can come with several configurations that make it very suitable for designing all kind of different application in all kind of different configuration. It works obviously in biflow with the same characteristic in both directions, and something that is quite nice when you start discussing about the regulation and the algorithm you have to develop to control the valve. it has a linear flow characteristic, meaning that you have a linear trend in between the mass flow you can have through the valve and the opening degree of the valve, which can be quite nice when you start to work with PID and that kind of stuff. It makes the regulation work much easier. And also, as I said at the beginning, it's compatible with all the new refrigerant, meaning it moved from Fontaine A, 454B, R32, propane, obviously, and even ZE. And it comes also suitable for all three applications. Obviously, all three applications normally are for much bigger size, but you can use those kind of valve for derivative circuits just for the cooling of your motor. For instance, if you have a turbocore, a compressor, you may need for cooling circuits just for the motor itself, and you can use those kind of valve to do that. So here is a summary of the feature of that valve. Actually, this is not just one valve. It comes in 4 different sizes, so you can really choose what is the best solution for your typical application and your capacity range and so on. So you have 4 different sizes of valve. It can go from 800 watts up to 22 kilowatts. So I'm talking about 14A. It's a unipolar valve, so very simple to drive directly from your main controller. You don't even need normally a big driver to do that. From the main controller, most of the controllers today on the market can drive unipolar valves, so you can drive. It can be driven directly from your main controller. It has 480 pulse, in total, so it gives you some granularity and some accuracy on the way you can open or close it. And you see here on the drawing, that's what I said before. It comes with very simple configuration, what we call the L shape here, but it comes also with the H or N solution, H or U, solution. So basically, you can start to imagine what you can do with that. After talking about the ETS 5M, there is also another product I want to introduce, and then we move to the other side of the ecosystem when it comes to size. So I've just discussed about the smaller one we had, the ETS 5M, and now we will discuss about the largest one, the ETS Large. So basically, up to now, there was only 2 different ETS Large in the ecosystem of Danfoss, the ETS 250 and the ETS 400. We will expand the family and introduce the ETS 175 and ETS 550. That will close the gap with the Colibri on one hand and with the manifolded ETS Large on the other end. That release will be done in several ways. In April this year, you will have the new ETS 175. Then in October, you will have the new 400. And in March 2022, you will have the whole family of products. So what are the features of that product and why we do that? Yes, I said the first intent of doing that was to close the gap with the 2 other kind of valves there was on the ecosystem, but also the new ETS Large, they have some more feature to improve the serviceability of it. You will see later on why it's much more easier to work with those ETS Large. And I was talking before flow characteristic with the ETS 5M. I will talk also with about flow characteristic with the ETS Large. You can have the typical linear flow characteristic you have on the ETS 5M and the Colibri, but you can also have the historical flow characteristic we have with the ETS 250 and ETS 400, what we call the S curve. I will explain to you why it could be beneficial in some cases to have both. And finally, but last but not least, those valves actually, they also come with different versions. One version for R3, one version for high temperature. Why we do that? Yeah, we started to see that in the HVAC business, more and more applications are requiring high temperature, such as heat recovery, district energy. More and more applications are requiring 90 degrees of condensing temperature, and for that we needed large valves. Because district energy, for instance, is addressed by large megawatt chillers. So that is why we developed that kind of valve, very suited for those applications, and come also in oil-free, because many turbocore chillers are used also for those kind of applications. So with those 4 products you see here, actually this is much more than just 4 products. This is 4 products for oil-free, 4 products for high temp, and 4 products for other applications. And you can double that because you have the S-curve flow characteristic, and it comes also with a linear flow characteristic. Keeping talking about the ETS Large, the first picture you see here, why I just said that this is easy serviceability. You see that ETS Large, if you want to do the maintenance on it, and I think you have to do that every year, you don't have to embrace the valve. You just have to unscrew the coil. You just check the coil, see that everything is okay, and then screw it back on the valve. So it's really improves the maintenance, really eases the job for all the maintenance people, and reduce the cost of your maintenance of your application. I was also discussing about the flow characteristic, and I will insist on this one because I think it's quite important to really understand why it's good to have both. We now have a kind of common trend along all the valves we have in the ecosystem, which is a linear flow characteristic. You see here the green curve here. So the opening degree versus the KV of the valve is linear. Historically, we had that S-shaped curve. Some of our customers, they liked it because you see when you are quite closed, very low opening degree, you have very accurate precision, meaning with some steps you have very few opening of the valve, so the KV is moving slowly. That could be very beneficial when you're, for instance, working at low evaporating temperature with fluids such as ZE. You need to be very accurate in when you're approaching low pressure, and for those kind of applications, so I don't know, heat pump, you work it with ZE, for instance, with very low evaporating temperature, that might be very beneficial to have that improved accuracy with the valve. So that S-shaped curve could be very important, very significant value proposition for many applications that are looking for that accuracy when the valve is quite closed. But if you're using multiple circuit chiller or multiple circuit anything, heat pump, for instance, and you have a colibri on one circuit and you need an ETS Large on the other circuits, then it could be important to have a matching characteristic. So meaning as the colibri is linear, the ETS Large should be linear. It's much more easier for the main controller to do all the job. Then you don't have to have specific algorithm for both circuits. You can probably mimic the algorithm you have for one circuit to the other one. This was for the valve. Now move to the last product I wanted to introduce, which is the EKF. EKF is a valve driver. This is not a superheat controller, meaning everything that I've presenting so far in the superheat controller, I was talking about the EKE and so on. There was some logic embedded. There was some program software algorithm put on the board to do all the job by itself. So the EKE superheat controller were as a standalone products. The EKF was introduced because we see more and more that the unit controller, like the MTX, they do the job. Everything is centralized now in the main unit controller, and they can drive small unipolar valve. But for larger valve, they miss some kind of power and they need some intermediate. That is why we introduced EKF, which is a pure driver. You plugged it to the MCX, the pressure and temperature sensor, they get back directly to the main controller. And then the main controller is just sending a signal to the EKF, which is amplifying it, translate that to something that can be understood by the valve. So basically, the EKF, you can set it quite easily with dip switches. It's pre-configured for all the Danfoss valve, but you can also configure any kind of valve. And for that, you need just a driver, a USB stick, sorry, and then you can upload the custom setting on the EKF. So the EKF board is just a translator of electrical signals that makes it very versatile, makes it very cost competitive. It can be also plugged with a power backup modules, which makes it quite nice in case of emergency failure, as I was discussing before. And last but not least, it has a status feedback. So meaning the main controller often wants to know what is the status of the valve, and the EKF is able to get the status and to feed it back to the main controller. So that solution allows you to have different kind of design. You don't have to get the superheat controller and just use it as a standalone or just use it as a driver. With the EKF, you can start to imagine everything that you can do with a driving valve. So it could be main expansion, could be gas bypass, could be defrost, anything. everything you need to know, even staging valve for turbo chiller, you can drive that with EKF. And that ends my presentation. If you have any question, I will be glad to answer it. And I thank you for your attention.
Thank you very much, Nathan. There are lots of questions coming actually about to which temperature we can use the ETS valve. So I think we fixed most of them. A question was about can we use them up to 120 degrees Celsius? So the replies we have is yes, it can stand up to 120 degrees. Some variants of the expansion valve are available, right? For
Yes.
high temperatures.
Yeah, for hot gas bypass, but yeah, I have to dig into this one because not all the valve can do that, and I think you need some specific version of it.
Yes, exactly. Okay,
so
there is
then
also.
Sorry, go ahead.
Sorry. Okay, a question about the availability with HVACR refrigerants. So I think you covered that and explained that it's compatible with most of them.
Yeah, it's compatible with most with all the new refrigerant A2L, so 454B, 452B, R32. Obviously, it comes along also with ZE, YF. I said propane as well. So all the valves now are certified for all those refrigerants.
Okay. There is also a question about A3. You said already, maybe.
Yes, propane, not for the large one, obviously, because you cannot put that much propane in a unit, but for the smallest one, such as the mini EV, which is very, very, very relevant for propane application, yes, obviously, it's already certified for that. And butane as well.
Yeah, and just to remind me, it's relevant to have that all characteristics are available in the cool selector. So anyone who is wondering about refrigerants can also find information in the ref tool or in cool selector, right?
Yes, ETS 5M is already in cool selector. You can find all the information you need. If you want information about the ETS Large, I would say that you have to get in touch with our application engineer. We can sample the valve already, and we have a lot of different information about this one. Not ready already in cool selector for all the different versions I've presented so far, but we can have all the data you need.
Okay. And there is another one I would like to ask you. What are the other applications that we can have with EKF, actually? With which other, it's not only to manage the expansion valve, right?
Yeah, you can. It's for managing expansion. It's for managing valve. We said expansion valve, but it's not for only the expansion of your HVAC circuits. Could be, as I said, for staging valve. If you have a turbo cold chiller, you need to protect it against something which is called surge, and for that you need to drive valve, staging valve, and DKF can do the job. No problem. You just need to. You need big valve for doing that, and then that is why you need an EKF to amplify the electrical signal. You cannot do that directly from the controller because you need bipolar valve and you need high power. So EKF is really suited for this one. You can anytime you need a colibri valve or any kind of valve, not only for main expansion just before the evaporator, for any kind of opening or closing the valve, you may use the EKF.
Okay, there are many questions coming. Another one is about is there a plan to close the gap between ETS 640 and ETS 12? Yeah.
Yes, there is a plan to do that, yes.
This is not a question you take openly about the roadmap, but this is maybe something we can discuss privately with you, Andreas.
Yes, this is part of the roadmap, so we can share it in private with whoever is asking it. But yes, be assured that we know that there's something to be done here, and we're working on it.
Yeah, and Patrick also is asking, does mini EEV integrate a stepper motor valve?
Sorry, I didn't get it.
Does mini EEV integrate a stepper motor? Sorry, a stepper motor.
Yes. They are all stepper motor. Yes.
All the expansion valves that we have a stepper motor.
Yes, exactly. Yeah.
So they are all compatible with EKF, you were explaining.
Yeah, but as I was saying, yeah, mini EV does not really need an EKF because most of the units they use directly the main controller to drive the unipolar valve. So mini EV, if you want a simple device, you just plug it to the main controller and it's driven directly by it. EKF are normally for bigger valve than that.
Okay. And there is also a very technical question here. I'm not sure we can take it right away. Can you explain the radiometric output as driver status? Or maybe you have the reply right away.
No, I don't have the answer right away. I think I need to get back to the application engineer to get this one right. But yeah,
Okay.
we write this down and just write this question down and the name of whoever asked it, and then we will get back to him or her.
Yep, I have already a few emails for you, Jonathan. Then we are at the end. It's very passionate. You're very passionate, Jonathan. Thank you so much for this discussion. And then, ladies and gentlemen, we wish you a great day. And don't hesitate to contact Jonathan or to contact the Danfoss team on Danfoss booth at Digital Mostra. And there are also much more webinars today and tomorrow about close controls, chillers, oil-free chillers, cold chillers, and the latest solutions. So you are absolutely welcome to join us, and we will be pleased to welcome you again. Thank you.
Thank you
Have
all.
a great day.
Il reste du monde là ou pas?
Non, we stop share.
Julie, comment stop broadcasting? Julie?